Okay, let's give some hints on the homework 25. First of all, part A, that's just watching the video and making conclusions from watching the video, so we're not going to get much help there. Let's look at problem B. Here are the visits, 3 successive activities: coffee and chores, visit to Y, and breakfast and shower. So we want to take the linear combination of that. Well, it's just x1, 1 times x1 plus 1 times x2 plus 1 times x3. You're going to have to define what x1 is. Maybe this is the time for coffee. I also don't drink coffee, so this wouldn't be me. And then x2, and etc. So then to determine the mean, well, you just take the mean of x1 plus mean of x2 and mean of x3, because 1 doesn't really add much to it. And then the variance for this time, you're assuming that they're independent, so this would be that the variance of y will be the variance of x1 plus the variance of x2 plus the variance of x3. There's no, take out the 1, you get 1 squared, there's not that much different. You're given that this is the standard deviation, so you have to square that to find the variance, and then you can find that out. Now let's talk about if you get up late. Let's maybe use a different sheet of paper here. Let's suppose that I don't know what your average turns out to be, but let's just, this is not quite this is fake start. Let's suppose that your average turned out to be 180 minutes. I would not convert this to hours. And let's say your standard deviation turned out to be, 120 minutes. Again, not the real answer, but this is just supposed to indicate what you want to do. And so an 8:30 departure means, well, you need to have that y is less than or equal to 180 minutes. So you'd have to figure out what's the probability then that z is less than what value. Well, let me change this to 200 because this is not going to work out as well just with the same one. So, so you do z is equal to x minus mu over sigma. So in other words, 180 minus 200 over the square root of 120. And you'd get a value that way, 180 minus 200 divided by the square root of 120. And so so you get negative 1.825, and then calculate 1 over 1.825, figure out this probability, do the norm CDF of a very large number to negative 1.82501, and then you get the probability. And figure out what's the likelihood of you making the time on there. All right. Okay, so that's just a hint on the first one. The other one you could do, you have to use the inverse z form. So let's suppose that you want a 90% chance for this, that the inverse norm of 0.9 Again, I think you're supposed to do 0.99%. and what you get is 1.28. So what you need to do is, if you have 0.90 equal to the probability of C minus mu over sigma, or the probability for our fake example, C minus 200 over the square root of 120 in our fake example, you would have to set this equal to 1.28 equal to C minus 200 over the square root of 120, and then solve for C, and then convert it into time. I think that's a pretty good hint. For part C then, problem C, suppose you invest 6%. You can just take the expected values of each one of those, use some calculus here. I think you can probably get these without it. And this extra credit, man, that's almost like a gimme. It should really be a regular problem. The other part of this then is, if you needed to do the time series example, let me go ahead and get out Minitab. Actually, I showed this on a video, so I don't think I necessarily have to do that here. But anyway, those are some hints to get started. If you have some other question, ask me on Discord, and we could take it from there.